simplify, we're trying to integrate 5x plus 2 over x squared plus 2x minus 8. All right, let's bring this over to our notepad. So this will probably take a little while because I see, this is a rational function. I think it was a plus 2, right? Yeah, plus 2, not minus 8. This is a rational function. It's a polynomial divided by polynomial, and there's a great way to do this, which is a partial fractions decomposition. All right? First things first, let's factor the quadratic on the bottom. So I need two numbers that multiply to 8 and have a difference of 2. 4 and 2 will do the trick. So we'll say plus 4 and minus 2. Okay? So what we've got here is, let's ignore the integration for a moment. We've got 5x plus 2 over x plus 4x minus 2. All right? And so what is the partial fractions decomposition? What's the setup? For each distinct linear term we have down here, we know we introduce a new constant. And so we get these are the partial fractions here. And they're not the full fraction, polynomial fraction, but if you add them all up, there you go. Okay? So for some constant a and some constant real number b, this equation is true whenever both sides are defined. Okay? So we just need to find a and b. That way we can make the switch. We can switch this expression for this one, and this is a lot easier to integrate. Okay, so let's find a and b. Multiply both sides by x plus 4 times x minus 2. You'll have 5x plus 2 is a times x minus 2 plus b times x plus 4. So what I'm going to do is I'm going to say, well, what makes x minus 2 equal to 0? 2. What makes x plus 4 equal to 0? Negative 4. I will plug these values into both sides of the expression to isolate for variables b and a one at a time. All right, so this is a great approach, especially if you got linear factors here. I mean, this can work. You don't have to specifically use zeros. You could just plug in a bunch of test values and get more and more detailed information, like 2 has to be a plus b, and then something like 3 is 5a minus b, and you can slowly work out from there. But if you can make some expression 0 so you can ignore the a and the b, do it. It makes things go very fast. So x equals 2, so that's 5 times 2. Is it plus or is it minus? Plus 2. So that'll be 12 is a times 2 minus 2, which will be 0, plus b times 2 plus 4. So that's 12 is a times 0 plus 6 times b. So 6b is 12. B must be 2. If we do the same thing with x being equal to negative 4, x being negative 4, so we'll get 5 times negative 4 plus 2 is equal to a times negative 4 minus 2, just plugging x in there, plus b times negative 4 plus 4. That'll be 0, so we can ignore that. 0 times b is still just 0. Negative 20 plus 2, that's negative 18, is negative 6a. So a is going to be 3. All right, what does this mean for us? The rational function that we want can be rewritten as 3 over x plus 4 plus 2 over x minus 2. These two are identical where they are both defined, and that's enough for our integration. So we want to integrate 5x plus 2 over x squared plus 2x minus 8. That's really hard to integrate, so instead we will split it up into the integral of 3 over x plus 4 plus 2 over x minus 2. We can split this up here. In fact, we can bring out the 3. Well, let's do it slow. So it's 3 over x plus 4 plus 2 over x minus 2. Bring out the constant of 3. Bring out the constant of 2. Okay. And now integrating this, not too bad. What this looks like, the derivative of x plus 4 is 1, so this looks like an f prime over f, which we might recall that's the derivative of ln of a function. So it's really quick to sort of undo this. This is just going to be ln of whatever's on the bottom. Ln of x plus, usually we like absolute values here. Ln of x plus 4 plus 2 ln of x minus 2. We do have to vary things a little bit. If it was like 3x minus 2, you'd have to take out a factor of 1/3. But we didn't encounter any of that this time. And we weren't asked for a definite integral, so there we go. There's our answer. You could use logarithm properties to try and condense this. I don't think we need to do that. We can just say, all right, there's going to be 3 ln x minus 4, no, x plus 4 plus 2 ln x minus 2 plus our constant because we finished our integral. And that's exactly what it is. So there we go. All done.